special live stream today in this Formula One world of, I don't know, how do we describe it? Technology, more high tech than we've ever had before anyway, 50%, maybe even more electrification of Formula One. And we've seen in the two Bahrain tests, and indeed in the shakedown in Barcelona, that it hasn't been easy for some teams, hasn't been easy for any teams really, let alone the engineers, the drivers, to do that. Oh, well, we got volume going on here. Okay, let's turn that down. It's a whole new world out there, isn't it? And very, very quickly, to the sound of muffled drums, the Australian Grand Prix will be upon us. So I couldn't be luckier to have such a wonderful guest today as Gavin White, who eats, sleeps, drinks batteries. I think it's probably the wrong way to describe it. But Gavin will tell his own story. He is Gavin, coming to us live from London, right? Where you're based?
Yes, from London. Yeah, thanks very much, Peter. It's a pleasure to be on the live stream. So yeah, we're based just behind the Tate Modern. Can you hear me okay?
Yeah, we seem to be all right. Are you okay? Audio
Yes,
wise?
yeah,
Yeah.
all good from my side, yeah.
Yeah, good. Sorry about that. Yeah. And tell us about your company and why and how you've gone about setting it up.
Yeah, for sure. So I'm Gavin, one of the co-founders and the CEO of About Energy. Background, I did mechanical engineering, studied at Queen's in Belfast, and always had aspirations to work in the Formula One industry. So I did something called Formula Student at university, where we built these race cars. And I actually worked on a battery electric race car back then. It was one of the first our university was trying to build. So that's what got me hooked on batteries. And I ended up doing placements at Aston Martin for about a year and a half before I guess I had a real passion for batteries. I could see that electric cars were coming. And from my university experience, it was quite clear that we didn't really understand how batteries worked. So I wanted to go and do a PhD in batteries to try and start a company actually in the battery industry. So
Wow. And how big a step was that at the time in terms of your peers, your mates? When you said, when you're down at the pub, what are you doing? Oh, I'm doing this. What are you doing? Oh, I'm into batteries. I'm going to study batteries. I mean, was it quite a big deal at the time?
it was quite a bold choice because I didn't even do chemistry at GCSE level. So to go and do a master's in mechanical engineering and then flip into batteries, which are electrical, chemistry, etc. But also I had a job offer, obviously, from Aston Martin, and that was quite a big deal because that was always a dream of mine to work at a company like that.
Mm.
So it was quite a big step to walk away from that and yeah, move into the world of batteries, especially do a PhD in London where the salary for a PhD is peanuts, and London is obviously very, very expensive.
Well, tell us about Aston Martin because obviously it's the Formula One team at the moment, right now, because of their battery issues with Honda. Well, let's get straight into that. If you got, can you add anything to that? Can you surmise what sort of issues they might be having with the batteries?
Well, batteries are super complex. There's a whole range of issues you could be having. I think probably the most common one is overheating, where the battery can get so hot that it can get into a situation where it could go into thermal runaway. So you might have seen them videos of cars that catch fire and start just exploding, and they're pretty much impossible to put out because as a battery burns, it releases oxygen. So it's basically can create a self-sustaining fire. So I think the biggest risk with batteries is, and maybe that's some of the issues they're having, is if you get into an overheating scenario, there's a risk of battery thermal runaway. So at that point, you need to curtail the power and let the battery cool down. But that's just one of a number of issues that you could be having. There could be electrochemical issues, electrical faults, etc.
What I mean, what exactly in terms of your company about energy? I think you've dabbled in motorsport and you do consult, right? I mean, how near to Formula One are you?
Yeah, well, we work on a lot of high performance applications. So what we do as a company is we have a battery testing lab where we test batteries under a whole range of conditions, and we use that data to build simulation models. So some of your audience might be familiar with the big simulation platforms like MATLAB Simulink or a GT Suite or Star CCM, etc. So these like 3D engineering simulation platforms. So we measure data that gets loaded into them platforms, and that allows engineers to design in the virtual world rather than having to build physical prototypes.
Hmm.
And that's Formula One does that to the absolute extreme, right? You probably know yourself how they simulate everything because they're
Hmm.
limited in the amount
Hmm.
of both wind tunnel testing time and physical track testing time. Um, so so what we do as a company is make them simulation models, and we do that for a range of industries, including motorsports, We work for a few billionaire rocket companies, satellites, these flying robo taxis, high performance automotive. Like McMurtry Automotive is one of our public customers alongside Mercedes and Porsche. So we have a lot of experience working these very, very high performance batteries, but obviously it is very confidential in a lot of them worlds, particularly the
Mm.
motorsport world.
But are you working with any current Formula One teams at the moment?
That's not something I could confirm or deny. We do work on a lot of motorsport applications, and I think that's probably as far as I can go.
Okay, let me ask you this. How many teams are making their own batteries at the moment, do you think? And how many might be using a battery made by an outside company or indeed another team?
So when you say battery, there's two elements, right? I think most people think of the battery as the battery pack, but inside the battery pack, there's actual individual battery cells. So the battery pack is made up of, yeah, often dozens, maybe even a few hundred individual cells. And my understanding is that um, about half of the teams are even making their own cells, let alone their own packs. So I think there's a mix in the grid where some teams are buying in solutions and maybe sharing some either cell designs or pack designs, and
Mm.
other teams are actually building their own cells, which is like right down at the chemistry level. They're making their own materials to go into their battery packs.
It sounds a huge new frontier for any Formula One team to be taking that on. And I guess it is, right? And that's what we're seeing right now with the testing.
Yeah, massively so. It's not just for Formula One, right? It's the whole of society. Like this push to electrification, whether it's your garden power tools or it's Formula One, there's like a whole new frontier of technology development. But like growing up as a child as an engineer, that's what always excited me was doing something new, pushing the extremes. Like I think we're really coming to the end of what can be squeezed out of combustion engines. So for me, it's exciting to have a new frontier where we're really at sort of, just day one
Mm.
of battery development. Like where it's going to be in 20 years is many, many steps beyond where it is today.
Right. Got some questions coming in thick and fast, Gavin. Everybody wants to try and get their head around Formula One at the moment. So, some of the questions I think are going to be fairly high tech. Others are going to be like mine, will be fairly basic. But this is from Zavesh Dagal. Yeah. The teams are using to recover this power. This power that can be so easily used. I don't know much about batteries, so please try to explain in not too complicated terms, basically what usage and recovery is all about and how that can be used to your advantage.
Yeah. So in Formula One, you have a battery which is a hybrid power system. So you have the engine and the battery pack. And the battery pack it discharges and charges every lap. Like they don't charge it up at the start of the race and deplete that like they do in Formula E. Formula One is a hybrid system. So they're using that battery to say boost before the straight or into through some exiting some of the corners. And then whenever they're going into a corner and braking, they're actually running the engine or the brakes to actually regen power to charge the battery back up. So the battery is getting charged and discharged dozens of times every lap, which adds up to hundreds of times a race and thousands of times over the season.
Right. Shout out to Edgar Domelendez. Thank you very much joining us as a membership as well, which is great. Actually, just have a look at this. Sorry, one second. Got to. Anyway, the next question is from Arshad Chowdhury. Why not allow full electric deployment every lap without recharge limits, just to make racing simpler? Then the drivers can always go flat out with the IC engine and not lift in the straights. But I suppose that's counterproductive to what you're interested in, correct?
Yeah. So what's the question exactly? Is it
He's
yeah,
saying,
why
he's
have
saying, I guess he's talking about the rules, really, isn't he? He's saying, why not just allow full electric deployment every lap without any recharge limits?
yeah, I guess the recharge limits are actually there to make the engineering feasible. If you didn't have recharge limits, the engineering challenge would be even more difficult, especially in this like first year of regulation change. So by putting in the limits, it puts bounds on the engineers as to like a design space to work in. The faster you recharge a battery, the more damage you do, which
Mm.
really affects the lifetime and also the safety implications. So by setting a regen limit, it makes it a whole lot easier to actually design something, especially in this first year of rules. I wouldn't be surprised in the future if we see that limit increase as we get more battery experience in the actual race calendar.
Right. Zabej Duggal says if the batteries can empty in half a straight, how can they recharge it over the lap? If they'd managed to do an 80-20 split, what will they do now when the split is 55-45? What are the tricks that they're going to be using?
Yeah, it's a great question. So generally, you can discharge a battery faster than you can charge it. That's not always true. And where that comes from is when you charge a battery, the best analogy I ever heard is think of like the anode in a battery, which is one of the electrodes, as a bookshelf, where when you're charging a battery, you have to get the lithium books and put them into the bookshelf. The problem is when you charge a battery really fast, the books can sometimes not slot in correctly, and then they can all build up on the front. And that's an irreversible reaction, and that's really damaging to the battery. So it causes a lot of capacity loss, but it also can cause these crystals to form that causes battery fires. So I think coming back to the original question is you can deplete the battery very quickly, say during that sprint, and then the rest of the lap you're recharging it at a slower rate. And you'll be recharging it both off the engine and from the braking zones in every corner.
Right. Good explanation. Russ Taylor, with an ICE motor and a battery motor and one accelerator pedal, how can a driver manipulate the power from each as he requires? Is it all manipulated by switch positions for each power source?
Yeah, it's a really good question. It'll be interesting to see how the teams do that this year, because I guess some of it's going to be algorithms, right? Like you can probably pre-program some of the battery deployment through algorithms, and then some will actually be from the driver, whether that's buttons or yeah, I'd be surprised. I don't know what your thoughts are, Peter. I'd be surprised if there's extra pedals in the car. That would seem complicated, but
Well, there wouldn't be extra pedals in the car. This is something we talked about with Mark Slade. A question came up about that as well, whether they have additional buttons on the steering. And he was of the opinion that the teams would just eventually have the same number of buttons. They'd just be doing different things because you just can't complicate it much more than we have at the moment. And it's hard enough as it is for the drivers, really, and the engineers. So I think, it'll be fascinating to see the different solutions that they all come up with.
I think that's where it might come back to algorithms. My understanding of a few years ago was they were programming the cars with GPS, that when the car was coming up towards a corner, it would actually trigger the turbo to start, or as the car was exiting a corner, it would trigger the turbo to start spooling up. So before the driver even got onto the throttle, the turbo was already pre-spooling based on just GPS location. So that's an algorithm development, right? That's something the engineers have pre-programmed into the car before the race. The driver has no control over that during the race. So I wouldn't be surprised if we start to see that with some of the batteries, say recharging or deployment, is that there's algorithms behind the scenes as well that the engineers are maybe working collaboratively with the driver on, but that's sort of pre-programmed in the race. Or I don't know, Peter, if that's something that could be updated live with regards to regulation, that the engineers could actually be updating that sort of thing through a race live.
I think at the moment, anything that they can do to make the racing more logical, easy for people to understand, and to get around a few issues that have appeared, I think they'll go for it. I think they'll probably be fairly flexible with the rules on that. But, obviously you can't control anything from the pit wall, and it's a fine line, isn't it?
Yeah.
Next question is from Drew. What's the difference between, well, you've kind of talked about this, but if you could just reiterate it, because some of our viewers might just be joining us. What's the difference between this Formula One battery and the Formula E battery?
Yeah, completely different technologies. Like they're both batteries, but that's kind of probably where the similarities end. A Formula E battery is designed to have really good energy capacity, because although there is tiny bits of regen, like every lap you're probably losing 90 to 95% of your energy. So you can think of it like your mobile phone at the start of a day, where in Formula E the battery is only getting depleted, yeah, through the race. That's why they have the sort of pit stops with the fast charge to top that back up. Whereas the battery in a Formula One car is a hybrid battery, which means it's getting basically at the start of every lap, it is always at the same state of charge. So through the lap, you use some of the energy and then you recharge it back up. But it means that the Formula One battery in every single lap is basically staying at the average same state of charge. And that has implications for the power. So a Formula One battery has much, much higher like peak discharge and charge to enable it to do that application. And it's a lot less energy dense compared to a Formula E battery. So the actual engineering inside the battery is very, very different.
Gavin, before we get on to the next question, just another one from me. What were you into as a kid? Were you very technically minded as a kid? I think a lot of people would be interested to know how you managed to get into this field and what made your brain tick from a relatively early age.
Yeah, I think it was really Formula One that inspired me into engineering. I used to watch it when I was like 8, 9 years old, and the bit I loved most about Formula One was the half an hour they did before the show where they talked about the technical developments. So I remember them actually going through like aerodynamic changes, changes in suspension design, like wishbone design, that they would sort of run around the pits and then try and explain it. And that was like to watch that every week and see engineering design happening live, I thought was incredibly fascinating. And for me, the pinnacle was Formula One because nowhere do you have the sort of the budget and the pressure to deliver changes so rapidly. So that's what got me really inspired. And then, yeah, my dad was a carpenter, so I was always very like doing hands-on stuff, building stuff. Like Lego would be a classic, right? But that's kind of what inspired me into engineering, and then that set me on the path to want to do mechanical engineering, get into engine tuning. But then it was when I went to university, I learned about batteries, and that for me, that was like engines were coming to the pinnacle of how much performance you can squeeze out of them, whereas batteries there was so much opportunity. So that's what got me excited about batteries and led to the PhD.
Brilliant that Formula student was very helpful to you, and you're now putting a lot back into Formula student, correct, as a result of that.
This has been incredible to do. I think there's over 20 teams in the UK we sponsor, and there's 50 worldwide. So we've got teams from all over the world, from Europe, USA, India, where we actually provide them with free models and data and simulation software to enable them to help them design their battery pack. So that's like a completely free sponsorship we do. And I think there's over 200 students now that have benefited from that program.
You've kind of covered this point as well, Gavin. Next question from Aaron. Hi, Peter and Gavin. How actively are battery makers involved in the team's development process? We're meaning Formula One teams here. And how has that changed, if at all, since last year or previous years?
Yeah, this will be massively so now. This type of battery chemistry that Formula One requires, there's a handful of applications in the world that require this type of chemistry. To give you some context, a typical battery typically operates at you measure sort of battery energy or power in something called C rate, which normalizes the battery size for the current. So imagine it allows you to compare, say, a watch battery to a car battery. So we talk about this metric called C rate, and a typical battery is kind of in the 1C to 5C range, and the like very high performance batteries are maybe 10, 15C. But what's required for Formula One is about 600C. Yeah, so this is not unlike any. The batteries in these Formula One cars are nothing like what you'd find in a watch, a phone, a laptop, a car,
Mm.
or even in Formula E. These are batteries that are used at extremely high powers that you might find in, say, like a laser system or a special rocket or something
Wow.
extreme. So there's very few people require this type of chemistry. So this chemistry will be being designed specifically for these Formula One cars.
Do you work with SpaceX?
I can't say which. We do work with a couple of billionaire-backed rocket companies, but I can't say which. The battery industry is incredibly secretive if you haven't picked up on that already, Peter.
Well, yeah, it is, I guess. But here's another secret that I'm happy to pass on a little bit. The rumor is, and I only mention SpaceX because it does have a Formula One connection through Dan Gurney, All American Eagles. Dan, great American race driver, produced arguably the greatest looking Grand Prix car of all time, won the Belgian Grand Prix in '67. Anyway, the family and the company still exists. And I understand, it's only a rumor, but I understand that they make all the landing gear for SpaceX, which is quite an impressive thing. And a lot of
Yeah,
that technology born of Dan Gurney. So if you're involved as well, then wow, look how aerospace is benefiting from Formula One technology these days. Kind of.
yeah.
It's a bit of a circular route, but worth mentioning, I think. Gavin, I'm also interested just to press pause again of how you keep on top of everything that's moving, all these moving parts now in your industry, because it must be evolving so quickly. How many competitors do you have, I guess, is one question. Probably a naive question because you're
Yeah.
probably unique, I would guess, in terms of the way your company exists. But beyond that, you've got this incredibly fast developing industry. And so is it a question of reading lots of books like the Lancet in the medical industry or what? How do you do that?
Yeah, that's a very fair question. But what we do is extremely niche. There's only a handful of companies in the world that do what we do, which is building simulation models of batteries. The vast majority of the time, when it comes to us selling to companies, is them building in-house capability. So it's probably something people working in the industry will could relate to. Is a lot of companies want to build what we have in-house because it makes sense, right? It's like the battery is so important to the Formula One car, to the automotive car, to the rocket that you need to have that capability in-house. But where we've seen an opportunity is batteries are so complicated and there's not enough skills in the industry that we've set up About Energy to help centralize that. And then you asked, like, how do we actually, keep on top of such a rapidly changing industry? And that's where we built really good relationships with the cell manufacturers. So all new cell technology starts with the cell manufacturers. So we built really good relationships with them, where they send us cells before they're publicly released, so that we can help characterize them and add them into our database. But that allows us to have foresight of what new sort of technology fronts are opening up.
Okay, then here's a really stupid question, but what is a cell manufacturer and how do they get to be cell manufacturers?
Cell manufacturers, some of the big ones are like Samsung, LG, Panasonic. So these are companies that are actually building individual battery cells. So in a car, you might have anywhere from 200 to 5,000 individual battery cells. So like a Duracell AA battery, that's an individual cell. Yeah. Now for a
Mm.
lithium-ion battery, they're slightly bigger, but not much, and they're about anywhere from 2.5 to 4.2 volts. So an individual battery cell you can't get electrocuted by. It's only when you add them individual cells together in series do you get up to the say like 600 volts or 1,000 plus volts that you'd see in automotive for Formula One. So cell manufacturers are the companies that make the individual cells, and battery pack companies are companies that take them cells and build them into packs. So that would be automotive companies, motorsport companies,
Mm.
satellites, scooters, etc.
Can you just go through again those cell manufacturers? I'm just interested in their geographic background and where they're based, which countries they're produced in.
The majority of batteries come from China. The vast majority of cell manufacturers are in China, and there's a lot of cell manufacturers in China, but there's a few really big ones. So you probably heard of BYD and CATL. So BYD also make electric cars. They started off making just batteries, but now they also make electric cars. But CATL would be the other big player, and they make just batteries. And quite interestingly, where CATL as a company comes from is a company called TDK, which you may or may not know, but they TDK were a company that used to build, these thin films for like cassette tapes, where you'd have magnetic tape on a very thin film. So that company actually spun out into what became CATL, one of the world's biggest battery manufacturers, because building a battery is actually very, very similar to building them sort of thin films you see in a cassette tape. You have these really thin materials that you have to coat the anode and cathode onto and build that. So a lot of that, unfortunately, due to just supply chain and cost, a lot of their manufacturers are in China at the moment. But thanks to like European and US regulations, we are seeing manufacturing open up in Europe and the US, but
Mm.
it's not even close to cost competitive. But what it is often the more high performance batteries, the more extreme applications, the niche applications. But yeah, the way it's trending, 95% of the world's batteries are going to come from China.
Have you been to China to look at that?
Not in my professional work at About Energy. I have been on various trips previously, but at the moment the Chinese market's quite closed. They develop their own cells, they develop their own packs, and then ship them internationally. We do test batteries from China, but it's not manufacturers that we have particular relationships with. We're more focused on the high performance batteries that are typically made outside of China.
Ali Rezazbar is concerned that when we see an overtake in Formula One, nobody's going to know actually why it's happened, whether it's aero, whether it's deployment, whether it's this, whether it's that. Do you think that we're going to get on top of it pretty quickly?
I think so, right? I think we're starting to see that they are gonna be a bit more flexible with the rules, taking on driver feedback to make it so that it actually is wheel to wheel racing. Um, I do take the point that we're not going to know if it was the driver of the car, but I think maybe people have been a little bit blind to maybe that's been the fact for quite a number of years. Like the engineering behind the scenes is not quite, it's never been clear whether it's the car or the driver, right? That actually generates that performance. I think now it's going to be even more difficult because it's going to vary corner to corner rather than sort of lap to lap or race to race.
Yeah. Another question, just pressing pause. You've mentioned Aston Martin a couple of times. Can you tell us exactly what you were doing there? I think it was the Valkyrie project, correct?
Yeah, so I was interning there for a year and a half. The first year was on the production line, actually helping improve the quality of the production cars. So like the Vantage was a big one, the DB11, and then the last 3 months I worked on the Valkyrie hypercar, which was a collaboration at the time between Aston Martin, the car company, and Red Bull Racing. Red Bull Racing's advanced technology. So Adrian Newey helping design that. But then I think the Valkyrie ended up maybe a year or two after I left, they ended up getting split and moved fully over to Aston Martin because Aston Martin created a Formula One team that then became competitive.
Did you have any interface with Adrian at that point?
I seen him one day in the office. I was only a merely intern at the time, so yeah, I wouldn't dare disturb him. But yeah, we actually shared the same office. I got to go to Red Bull Racing 3 days a week, which was honestly my the dream job at the time.
And what was he doing in the office? I mean, when you say the office, was he at his drawing board or was he in a different office?
Oh, mainly shuffling between meetings and yeah, speaking.
I think we're all fascinated to know how that's all going to evolve. What's your take on the whole Aston Honda situation right now and the trouble they're obviously in, and how long do you think that will take to sort out?
No idea. It's obviously a bit of a crisis, right? That's a very, very bad start to a season, but maybe it's just precautionary. This technology is extremely new, and they have such limited data on how to deploy this technology that I hope it's just the fact that they're erring on the side of caution, and that they'll actually come out in the season a lot stronger. But knowing Adrian Newey, I'm sure it won't be long until they have a good solution as a team. So yeah, I don't know if you have any extra insight on.
Well, if you're suggesting maybe it's an overheating thing, I mean, how big a deal is that? And normally, if the brakes are overheating or the oil or the water temperature is running too hot, Formula One teams know how to solve that problem. Is it a similar solution in terms of cooling ducts and so forth for batteries, or is it a totally different thing? Is it an internal solution they're going to need?
Yeah, so there's the mechanical side, which is like the cooling ducts, the structures, the materials they use to actually conduct the heat out of the battery. But then you've also got the control in your software and your algorithms that control, say, how the battery charges, discharges. You can do clever things like pulse a battery, which allows it to charge and discharge maybe a bit more efficiently. So there's a whole range of controls, both software and hardware, that you could use to try and fix them problems. But also it could be sensors, right? You could have sensor faults. Maybe you need to do more calibration to calibrate the sensors to the hotspots in the battery. So there's a whole range of potential solutions you could come up with to fix issues like that.
Ashen Sandaruan says, how can competitors gain a competitive advantage in battery related areas in Formula One? What would you, if a team's doing well, usually what will that mean from a battery perspective? What are they doing right with the battery, I guess, is the question.
So my personal perspective is that teams are going to be made and broke this year on the battery performance. The battery is just going to be the single biggest contributor to a team's success or failure. And there's two reasons behind that. One is it's such a new technology, so it's basically the teams are starting from a blank slate again. But two, when it comes to batteries, squeezing the performance out of the cells is extremely difficult. It requires a lot of knowledge and expertise. And that's not something the teams have had traditionally, right? It's like squeezing the absolute maximum juice out of a battery. So to give you an example of what I'm talking about there is I talked about that in a battery you have to combine lots, dozens, maybe even a few hundred cells together to form the battery pack. Well, often you're limited by, say, the weakest cell in the pack. So if you have a cold spot in your battery pack, then them
Mm.
cells are going to drag down the performance of the rest of the pack. So you need to design your battery pack to keep a really uniform temperature, to keep a really uniform current flow between all these cells, etc. So when it comes to engineering, that's where you can really make the difference is things like keeping uniform temperature gradients, uniform current flows, having really homogeneous cells. So every cell is similar to each other. And that's the difference between squeezing, say, I don't know, 95% efficiency out of a battery pack compared to, say, 85%. And it's that 10% or 5% efficiency gain on the battery pack that I believe is going to make or break a team this year.
Fascinating. And segues onto this next question, actually, which is just jumped as I was about to take it, but no, it's gone now. Oh no, here we are. Sorry, just Okay, sorry, this is from Ben. Is the deployment all or nothing? Can you use, for example, 20% for a longer period and build up a strategy around that in Formula One?
Not really. When it comes to the battery, you kind of need to discharge and charge completely within a lap. Yeah, I'm not quite clear if they'll be able to carry over some energy, but the battery packs haven't been designed to do that. So that's what
It's
would make
not
it.
designed to do that.
No, they're
No.
not designed to store a lot of energy to then carry forward in laps. So it's kind of like, yeah, the deplete and use within a lap is going to be the most common use case. There might be a possibility to carry over a little bit of energy, but it's not going to be significant enough to make a big difference.
Mm. And Ben, following on, and we've kind of touched on this already, but again, to reiterate the point, what are the teams going to be allowed to develop within the battery? Or is it pretty fixed like the engines once they've got it in place?
I
The
think no, I
ICE,
think
that is.
yeah, I think with the battery, a lot more is open. So they can change the chemistry, they can change the cell geometry, the cell design, they can change all their connectors, their coolant system. So it's really a blank sheet of paper when it comes to the battery pack. They've defined in the regulations like high level specifications, but within that, there's a huge amount that they can change. And,
Right.
and that's very different from like the KERS system and the energy recovery systems, where they were a lot more constrained and fixed, and the battery was a lot smaller. So that's why I think the teams and drivers are seeing such a big step change, because this is like it's transformational compared to what they were doing before.
Again, from Ben, another good question. You mentioned C rate. Typically, the degradation falls in line with C rate with charge and discharge. Do you think there could be strategy on how hard the battery is used to preserve its life? It's a little bit like the previous question, I guess, but interesting
Yeah.
one.
No, it's a really good
Yeah.
question. Very knowledgeable one as well. And yeah, I think that's definitely going to come into play. I can't remember exactly the rules, but I think, is it Peter, they're allowed two different batteries through the season? Are you familiar with the rules?
No, I'm not familiar with that part of the rule. No, it's a good question, isn't it? I've no idea. I would imagine so. Yes, if they start limiting it like that in the
Yeah.
first year, I can't imagine they would they?
Yeah, I think the battery pack, they're allowed maybe two battery packs through a season, but I would need
Mm.
to double check that. But the point being that the battery packs need to last more than a qualifying lap or more than a race. So these battery packs need to be able to perform at that level for multiple races in a row. And Ben raises a great question, which is batteries degrade. We all see it in our mobile phones or laptops. 2 years later, and your battery only lasts half the day instead of a full day. And that's going to happen to these Formula One batteries as well, where after 4 or 5 races, they're going to be in a degraded state. So what you do to manage that, whether it's an automotive car or a satellite or a Formula One car, is you actually limit the performance at the beginning of life to ensure that you get the end of life performance. So
Ah.
that is something that these teams are maybe going to factor in, that in certain races, they might be like, this is a race we have a really good opportunity, so let's degrade the battery a little bit more and push harder. And then in the next race, they might need to conserve the battery a little bit.
Just touching on that, how recyclable are the batteries these days in general terms?
Generally, it hasn't been great, but it is getting a whole lot better. And I think in the next few years, it's going to be really good. So how a battery is recycled is it's generally put into a massive shredder and ground into what they call black matter. So you take the whole battery, casing, everything, and just grind it into just basically a fine dust. And the traditional process from there has been take that fine dust and put it into a furnace and just melt it and recover the aluminium, the copper, the nickel, the cobalt. But unfortunately, then you're burning away a lot of the active material. You burn away the lithium, all the plastic. So the recovery rates maybe, I don't know, 50, 60% through that process. But new processes are coming online where you take that black dust and you use water-based processes where you can actually recover the lithium, recover the plastics, and that's going to bring the recycling content up a lot higher. So when it comes to battery recycling, it's trending in a really good direction. That the problem is there's no volumes at the moment, Peter. There's not enough batteries to recycle to get economies of scale. So over the next few years, we should see more and more electric cars actually reaching the end of life, which is going to open up the recycling processes.
Yeah, I mean, that's one of the stories in the pit lane that there are not many batteries around. And that's indeed why some teams maybe limited the amount of laps they were doing because, as you say, it's going to ramp up very quickly, but pretty sparse on the ground. But beyond that, can I just talk, Gavin, again, this is probably a stupid question, but where are we at in terms of heading towards solid state batteries?
Yeah, well, solid state's been talked about for. I remember when I started my PhD, quite famously, I said to my PhD supervisor, "Why are we working on lithium ion? We should be working on, the next generation of technology, whether it's supercapacitors or solid state." Um, yeah, like 5, 6 years later, it's obvious why that's not the case. These technologies are always flouted in the news. They make for really good headlines, because they're going to, a step change in technology, but they're so difficult to manufacture. I think what people don't consider about batteries is it's not about what you can achieve in the lab, where the battery is the size of a postage stamp. It's, can you manufacture that at scale, at cost? And the challenge with solid state is that you can't. One of the big challenges with solid state is because there's no liquid electrolyte, you need to get your anode and your cathode to really simplify it, and you need to push them together really hard so that the lithium ions can move. So that's all well and good, but then imagine you get loads of these batteries together. Imagine the size of the case that you need, and you need to be able to exert maybe 5 to 10 bar of pressure on the battery pack. So you're talking a massive steel case, you're talking massive nuts, bolts, screws, springs to squeeze that together. So although the battery is more energy dense and more efficient, as soon as you scale that to a pack, you've lost a lot of that efficiency. So it's never as simple and as clean as the headlines. So I don't think that we're going to see this big step change from solid state in the next few years. But what we are seeing is incremental improvements, such as lithium metal is a new chemistry that's shown a lot of promise now.
Okay, well, we'll wait for that one. Where's that produced? Where's that metal come from?
Yeah, well, this lithium metal cells have been commercialized for the first time in the last year, and there's I believe it's two South Korean companies are the first to get to volume production of them
Hmm.
batteries. So we've recently just tested them batteries, and they're extremely high performance.
Wow.
They're maybe 50, 60% in both energy and power on a traditional lithium-ion battery.
Excellent. Savage Dougal again. How will we ever actually have a completely electrically powered rocket or ship? Big ship, I guess he means.
To go to space, I guess. Yeah,
Yeah. Or
absolutely.
and let's talk about a huge freighter as well.
Yeah, absolutely not. It just doesn't make any sense. Um,
We
yeah, when
might as well throw in a 747 there as well.
Yeah, it's certain applications like transatlantic flights, international shipping, they're never going to be electrified. Batteries just don't have the energy density required to do that. You could potentially have hybrid system on ships where you're using, I don't know if you've seen some of these technologies now where they use like wind turbines on ships that act as both a sail and as an energy generator, which could charge up at, say, a hybrid system. So yeah, you can imagine a period of, say, a few days of really windy conditions. You charge up a battery and you use that for the next few days. But that's not going to get you on your, 2, 3 month journey across the Atlantic. And the same is true for planes, transatlantic. The amount of energy you need to actually transport something like that for 10, 15-hour flight, it's just going to be unachievable with batteries. Same is true for like spacecraft. It's just impossible in terms of the energy balance. But there's other hybrid technologies, whether it's hydrogen fuel cells, hydrogen combustion, methane. Like there's lots of other technologies that are a lot more suited to them applications.
What sort of watch have you got, Gavin? Big battery on that one? Serious battery on that watch?
I wouldn't say it's serious. To be fair, the Garmin's last like 10 days. I used to have an Apple Watch, and yeah, every day you had to recharge it, whereas the Garmin's are a lot better.
Okay, well, there you go. Another good question from Ben. Do the track marshals at Formula One races now need to be aware of anything different with regards to safety with a stationary car or a car that's been crashed?
Massively so. There's obviously the electrical hazards, so electrocution. So these batteries are going to be well beyond 600 volts. So a short circuit across your body would absolutely kill you. And that's like 3 times higher than the electricity you have in your house. And then there's obviously the hazard of fire and explosions. So I think we've seen in Formula One how they've managed that very significantly, right? Where cars don't just burst into fireballs the way they used to 20 years ago. So there's a lot of technology's gone into actually containing the fuel and the fuel systems. But yeah, the way a combustion car would catch fire and explode would be very different from how a battery does it. So there were a whole set of new hazards for them to be aware of. But fundamentally, you need to get the driver out of the car within the first 30 seconds, just like in a combustion
Mm.
car. But I guess it's the hazards beyond that of like how do you actually recover the car? You might have heard stories about how electric cars have sort of crashed or caught fire at the side of a road. The fire brigades put them out or declared them safe. Then a tow truck comes along, puts the car on the back of the tow truck, starts driving down the motorway, and the car catches fire and then burns the tow truck down as well.
Hmm.
So the same is going to be a serious hazard for Formula One cars, that when they go to recover them on the side of the track, they might look fine and they might look safe, but 5 minutes later they could catch fire from the inside. So these are hazards they're going to have to manage with, say, the recovery of the cars and bringing them back to the pits. That it can take many days for a car to be guaranteed to be in a safe condition.
Wow. Wow. Well, I hope everybody's in power is listening to that right now. I'm sure they've been thinking it through and talking it through, but important words from you there. And can I just ask another question on that vein? When we had the massive fires in California, a couple of years, I think I can't remember when it was, a couple of years ago anyway. There were stories of electric cars just exploding if they were not struck by lightning, just from heat. Is that
Yeah.
right, or were they exaggerated?
Well, they can do. So, if a battery overheats, it will catch fire, and if it catches fire, it can go into thermal runaway, which is a like an unstoppable runaway reaction. And where that comes down from, like in the battery, you're storing huge amounts of energy. In your electric car, you have enough energy to power your house for 2 days off grid. So think of all the energy you use in a house for 2 days. That's all stored in your battery pack in your car, which you sit on top of. So all that energy is contained and it's separated by the thinnest sheets of plastic you could imagine. So in between your anode and your cathode, you have this really, really thin sheet of plastic that separates them, and that's what keeps the energy apart. But if the battery gets too hot, that thin sheet of plastic that separates the anode and cathode can actually melt. And if that melts, the anode and cathode will start touching together. And when they start touching together, they release energy, it generates heat, and that ignites the thermal runaway reaction. And yeah, because the lithium or because the electrolyte releases oxygen as it burns, it's a self-sustaining reaction. So the only way to put it out is to suck enough heat out of the system that the fire just can't sustain.
Mm.
But that's very, very difficult to do. You can imagine it's all cased in a big box. So coming back to the California fires, you probably had electric cars that were near the fire, and when the ambient temperature gets above like 80, 100 degrees, the plastic inside the battery is going to melt, and that's going to cause the battery inside to short circuit, go into thermal runaway, and then explode. So that's
Mm.
where it comes from, and that's exactly what I was talking about with, say,
Yeah.
the marshals on the track. Is like that's a hazard that didn't exist before.
But I imagine that thin film of plastic that you just described is an area of massive development, right? Because they want to have something that's a lot more preventative than that. I mean, is it really just plastic?
Yeah, exactly. I'm really simplifying it that it's like a thin sheet of plastic, but it's hugely engineered, and companies spend a fortune on the development of these materials. What it's actually is if you were to really zoom in on it, it looks like a fishing net. So it's actually a porous sheet. If you held it in your hand, you would think it's a solid sheet, but if you zoom in with a microscope, it looks like a fishing net in terms of it has lots of holes to allow the lithium to move across. So it's basically what separates the anode and cathode, which means the electricity can't travel across, but the lithium ions can travel through. And yeah, huge amounts of work goes into engineering it, into developing materials that have higher and higher melting points. But that's the challenge: is how do you make a material that's electrically insulating, is super thin, has holes in, and yet doesn't degrade at say 130 degrees. It's a very, very difficult problem to solve.
I think this next question will make you smile, Gavin. It says, this is from Tobacco Road. I'm going to add one little piece into this question is, how does one go from intern to, I'm going to say, high powered CEO in less than a decade? And already there's an answer from Darwin Living who says, by being good at what you do. But over to you on that one.
I don't know if you describe me as a high-powered CEO. So it's still a relatively small company. I think the CEO in a small company is effectively just a manager in a
Well,
big company.
it was a bit of a pun on the nature of your work, but anyway.
Yeah. But yeah, in terms of how I did it, was always wanted to start a company, and I didn't really know how to do it. But I read Elon Musk's book years ago where he described how doing a PhD is a great way to start a business, because you get 4 or 5 years of study where you have access to millions of pounds worth of equipment. You have very little supervision, and you get paid a salary. So it's a great breeding ground to develop new technology. So that's what inspired me. And through my PhD, I always pushed to try and find an opportunity to start a company, and stumbled across sort of battery modeling was being done by every company individually, and it's super inefficient. So the opportunity was, if we can centralize that, drive down the cost, and increase the performance of these battery models, there might be an opportunity. And yeah, we've been going for 4.5 years now, and yeah, very lucky to work with some of the biggest brands in the industry.
Brilliant job. Congratulations on all of that, Gavin. Another question from Ali Rezabaka. We've had him before. So, based on what Gavin is saying, the deployment is 100%, this is Formula One, except in the normal mode when it goes down by 50 kilowatts every second from 350 kilowatts to zero. Is this correct?
I don't know enough about the regulations and the implementation as to exactly how it's going to work, but it's definitely a system in which you charge and discharge through a lap. You're not storing, you can't basically store energy at the start of the race and use it at the end of the race like you can do in Formula E. So that's where it's distinctly different. I'm not fully up to speed with all the different charge and discharge limits and the exact usage conditions, but I guess that's going to become super apparent in the first races. And coming back to what you said earlier, Peter, I think it's
Mm.
quite clear the FIA are going to be a little bit maybe potentially relaxed.
Yeah.
And I think we might see the rules change relatively quickly in them first few races to make sure it's something that both the drivers and the fans can actually get behind.
Martin Lee says, Gavin, thanks for your unique insight. And I obviously second that. Tamako wrote another question. It's quite funny, this one. My father was a PhD mechanical engineer who worked on the USS Enterprise and Blackbird turbines, but was never anywhere near the CEO of Westinghouse or Pratt and Whitney. LOL. But yeah, two pretty cool things to be involved with there.
Cool,
That's
yeah.
and that's where, just in passing, that's where Enterprise rental cars comes from, because
Is it?
the founder of Enterprise
Okay.
rental cars was on the USS Enterprise
Oh, fair.
in
And he
World War
named it
Two.
up.
So
Well,
there you go. You know, that's so we should all rent cars from USS Enterprise, I think, from Enterprise anyway.
yeah.
Um, this is not a very pleasant question, but I suppose it has to be asked. In the case of a Romain Grosjean type accident, is there therefore also a risk of the driver now getting electrocuted?
There would be if it wasn't for all the safety and then the engineering they put in place. Obviously, we don't know all the details, but I'm very, very confident that them voltages will be very well insulated from the driver, both through the chassis and through the casing, etc. So there would be a super remote chance of that happening, but I'm sure there'll be many, many layers of separation, like
Mm,
insulative separation. But also,
yeah.
the driver's suit isn't electrically conductive, so it'd be very difficult to get electrocuted unless it was in direct contact with your skin.
Well, a straight answer. Thank you for that one. These new batteries in Formula One, what real world applications will they have beyond typical life? The large discharge and charge rates with big charge cycles, they're almost like a pseudo capacitor.
Yeah, I think the only other application I've seen for the direct chemistry could be used is in laser systems. So you might be familiar with these new military like laser systems where to like shoot down drones or other things. Them lasers use huge amounts of energy that need to be used in just a fraction of a second. So they use very, very high power batteries to actually release that energy for them systems. But so that's like a super niche application, right, for all this technical development. But I think this is where people misunderstand that Formula One isn't about developing technology that can then find other use cases. I see it as it's a Formula One is about developing the skills, and them skills are super transferable. And it's also about like motivating and inspiring like the next generation of engineers. I think many people probably grow up wanting to work in Formula One and then get to university and then go down a different track. So I see the impact of batteries in Formula One and this technology being a lot more widespread than just like its direct other uses for other industries. I think it's really about the skills development.
Um, a question about the abolition of MGU-H in Formula One. What are your thoughts on that, Gavin? Are you aware
Um,
that that happened? I mean, basically, it was to Audi said we're not going to come in unless you get rid of it because we never used it on our world endurance cars, and so the FIA said, okay, we'll no longer generate energy from the MGUH.
not fully up to speed. I don't think it was going to affect that much. I think there's enough to play with now between the battery hybrid system charging off the like the engine as well as yeah the actual engine driving performance as well. So I
Mm,
don't see it being a massive limiter to say yeah Formula One.
yeah. Gavin, been so generous with your time and brilliant to have your insight. And I think you can see there from the number of questions we've had how how fans are thirsty to understand
Recording
all this. It's
stopped.
not difficult, but it's we just had the recording stop. That was your end, I think, on the Zoom call. But I'll tell you what, though, I think things are going to happen this year, and we can't predict what they're going to be. It could be a major overtake. It could be something happening on the last lap of a race. It could be something else that we can't even imagine. And so what I'm saying is I'd like to have you back on the show again if we can this year, if you're up for that. Certainly
Yeah,
more than once again this year, because just fabulous to get your insight. You know, you're right there in the cutting edge of what currently Formula One is all about. So
yeah, I would absolutely love to. Really appreciate you having me on, Peter. I would love to come back.
no, great pleasure. And just tell us a little bit about your office again there before you say goodbye. What your average working day is like, and you're in that area there. That what did you describe it as? You're under the arches of a railway line, right?
Yeah,
In London.
we're super lucky. So we have our own railway arch here just behind the Tate Modern in central London. So downstairs we built our own lab where we do all of our battery testing, and then upstairs we have our office. So yeah, it's based just between Waterloo and London Bridge. Typical working day. I'm very commercially focused now, so I do a lot of the sales calls. So probably a third to a half my days on sales calls with customers, and then the other half is the sort of management of the team as well. But yeah, everybody's very technically focused. I'd say 80% of the team is from a very highly technical background, including probably about half of that is PhDs.
Brilliant. And for those that don't know, and perhaps not familiar with London, the Tate Modern is a wonderful piece of architecture, which obviously encases modern art and lots of empty space, as you would expect in something like that building, a bit like MoMA, I guess, in New York. And I can't think of a better place for your company to be based, really, right next to that. You must get the vibes from the Tate Modern, I would imagine, because nothing could be more modern than your technology.
Yeah, well, we're super lucky that in a say a one-to-one meeting, we can actually walk over to the Tate Modern. It's a 5 minute walk. We can walk around the Tate Modern having a one-to-one.
Mm.
So it's like a nice break. It's nice, like refreshing environment.
What have they got going on there at the moment? Do you know?
It's always usually I don't know what the latest exhibitions are, but yeah, it's usually a lot of the same stuff, isn't it? And then it's like circulating exhibitions on the top floor.
Well, Gavin White, About Energy, great company, doing a lot for Formula Student now as well with their sponsorship, and doing a lot, as I say, right at the front of Formula One's energy and technology as well. Congrats on everything you're doing so far. Best of luck for the year ahead, and thanks very much for joining us, Gavin.
Yeah, I really appreciate it, Peter, and to the audience, especially for the questions.